Thank you so very much for joining us today. We've got a very exciting panel of speakers here to talk to you about some latest developments with the anaerobic digestion sector, as well as other things happening in the world of compliance and decarbonisation. So we will be going through the housekeeping for today's webinar, and I'll give a little introduction for NFU Energy and myself. We're then going to be going through our speakers in following order. So Kieran from Calico, who's environmental consultancy, will be talking to us about BAT, so best available techniques, and other requirements that are necessary for AD, as well as just broad permitting as well. We're joined by the Environment Agency this morning with Jan and Emma. So big welcome to both of them. Talking much more about changes in ongoing compliance and permitting, exemptions, and there's been a lot of discussions about carbon capture, decarbonisation, readiness and stuff for consultations at the moment. So they're going to be talking about all the changes going on with that, as well as the medium combustion plant directive for engines and boilers. We're then going to be moving on to David from Purigen, who provide purification options for abatement plants that are necessary for AD. So short and sweet. So we'll go into housekeeping. As you can tell, the webinar is recorded. Please keep your cameras and mics off for the duration of the talks. If you have any questions during any of the talks, please use our Q&A function. More than happy for you guys to chat in the chat, but if you've got any questions, please keep them to the Q&A section. We'll do our best to answer all of them in the time that we have, but we are, of course, eager to let the speakers finish. So if any questions are not able to be answered in the time we have, we will be providing full responses via email with a copy of the recording after the events. So we've got about 50 minutes, hopefully, and then we'll see how much into the 10 minutes of question time we get eaten up. But I'm very eager to let everyone talk because it's all very important stuff. So a little bit about us. So I'm Sophie. I'm an environmental compliance consultant for NFU Energy. We work with mostly for horticulture and agriculture, so farmers with the National Farmers Union, but we are open and work very heavily with a lot of industrial clients and sectors. And as well as having a full team for projects and compliance and energy and account management. I do recognise some people here today, some of ours, so welcome and thank you very much for joining us, and also a lot of new faces as well. So we are predominantly an energy consultancy, but we do have energy brokerage and such as well for contracts. So we are very happy to host the webinar today and be able to bridge the gap between yourselves and those who are talking. So I will not waste any more time. I'll get that speakers come here, let them get on with what they came here to do. So we will be moving on to our first speaker, which will be Kieran from Calico. Thank you so much, Kieran.
Thanks. I have just requested to control the slides, so hopefully they'll come through. Yeah, while that's happening, a quick introduction to myself. My name is Kieran Laxton. I'm a director at Calico Environmental Consulting. I've only got about 10 minutes to talk, so I'll be sort of trying to cover quite a lot quite quickly. But the focus of the talk will be on obviously AD operations which require permits rather than ones that have exemptions. And a lot of it's going to be super sort of high level overview, in part to tee up the next presentation. So I'll mention some things that will then have more detail later. As with most things, the areas to cover are huge. A lot of the content will be focused on England, where the EA are regulators, but a lot of the concepts also apply to Wales, Scotland and Northern Ireland as well. Have I got control? I don't think. Could you do the next slide if possible? Thank you. So just to say, teeing up stuff, super useful. Just mention what's the purpose of permits, and obviously it's all about managing risk, trying to minimize as far as possible, and that needs to consider various different concerns. And the concerns are at sort of a local level, and they consider the impacts on the area immediately around, so that's odor, water, noise, vibration, dust, aerosols, and air quality. But then also you have a slightly more broader area of influence, and that's where things like air quality can impact, but also climate change and the release of methane and greenhouse gas emissions. And that also applies both nationally and internationally. So there are different spatial scales of consideration that needs to be thought about when doing it. Now, the fun of this all is that with permits, because we're trying to minimise risk, that does to a certain degree for operators mean that the goalposts are sort of continuously moving because there's continued improvement required. But the Environment Agency do provide really useful guidance. And I put as a screenshot in relation to some of and there's links on all my slides as well, for the guidance in terms of what's relevant to us. And I feel that the guidance is changing from sort of really specific guidance about how to comply with the permit now to focusing much more on management systems and emissions monitoring and control. So it's sort of the guidance is helping operators understand exactly what they need to do to continue to operate afterwards, rather than just apply for a permit, which is certainly useful. Next slide, I think I can now take control. Yeah, cool. So BAT is often used in a term that's thrown around a lot. BAT stands for Best Available Techniques, but actually, in the context of AD operations, appropriate measures is the phrase that's typically used, and appropriate measures covers two slightly different frameworks. So it has all the BAT measures, but also the necessary measures for waste operations, and it's merging those two things together. A lot of people seem to forget the second half, and again, the EA or the government website has really useful instructions of what the appropriate measures are, and these are the measures that are sort of typically expected for operators to use. And all new facilities must implement the relevant appropriate measures, or alternatively justify why they haven't, or justify an equivalent measure that satisfies the same purpose to minimize risk. And they must be in place before operations start. The existing operation also should now be applying appropriate measures, because there's a time frame for people to get up to speed. Next slide. Does this bring on to? Thanks. So what does BAT mean for me or for an operator? Well, AD facilities are all required to adopt BAT, which we just said about before, but BAT has a series of emission levels that are required. So for any release to the atmosphere or to water or to ground or surface, there are specific requirements that you have to comply with, and these are set out in the various different documents. The most useful one is a BAT conclusions document and a waste treatment breath document. These are what set out the good measures that you want to do. Those are hosted currently for the waste sector. That's hosted on the European websites, which is where they currently are. They get reviewed and updated periodically, and since leaving the EU, there's UK BAT conclusions, which are slowly working through different documents, and the waste sector's for waste treatment's not quite there yet, but in the future it'll be UK BAT rather than the EU BAT. But that BAT document's been around for quite some time now, 2018. And there are some other useful documents, like I've put down there. There's a screenshot for SEPA, so that's Scottish Environmental Protection Agency, their interpretation of BAT conclusions. That was in 2022. So it's just useful to be aware of what's the most recent documents. Next slide, if possible. Okay. So I thought it was just useful to say here sort of current priorities for AD plants. Now, emission control is obviously one of the big key things, and this sort of covers things like continuous monitoring of methane and ammonia or CO2 emissions. And it also covers digestate storage, making sure gas-tight systems, or implementing using advanced flares or biogas upgrading technologies. Energy efficiency is another key priority for BAT, and this is about optimizing heat recovery, and that's definitely highlighted a lot in the BAT conclusions documents. Then there's digestate management. This is about improving handling and nutrient recovery for systems. So obviously, when digestate leaves the system, leaves the site, there's secondary effects that we make sure we're minimizing, and so getting nutrient recovery is important for there. And there's a circular economy agenda, which is starting to suggest that things like more just-in-time feedstock delivery to minimize the amount of feedstock given on the site. And then I put down air quality and odor because they're things that we tend to see need to be addressed in a significant way. There's obviously other things like water and bioaerosols, but those two come up a lot for us. One of the challenges that we've sort of seen again, and it's the reason I put these pictures down, is actually a biofilter, which is used for odor abatement. But the standard emission limits they're put on those are actually quite stringent, and they are just generic emission limits. But biofilters give off a natural odor as well, so they can actually exceed those emission limits just naturally, and often there's not consideration of how close the receptors are to the site physically, and obviously it's receptors, the impact on receptors that matter. So sometimes you have to work to try and make those more appropriate to the site, but that's the purpose of the pictures. Can you go to the next slide? So I thought this was quite a useful thing just to mention. I've just got a couple of quotes there, which I'm not specifically going to read out, but we get asked questions, and for me, the useful thing to say is that permitting is useful to consider it as quite a binary thing at first. So if something's written down in your permit, you can do it. If it's not, then assume you can't. And I will say that my experience is the EAR and the regulators are pragmatic, and they will consider things as, say, their objective is to minimize risk, but don't assume you can just do something straight away. And the fun during the permit application stage is that it's often quite a chicken and egg scenario, where as an operator, you're trying to convince the EA that you're going to operate a site and it's going to be low risk, and the EA need the evidence to support that. But the details aren't always available at the application stage, and so you have this sort of slight chicken and egg scenario. And I've just put the screenshot on the right is an example of a more bare bones set of evidence has been submitted, which I personally don't think would convince me if I was a regulator that facility is going to be. I wouldn't have the confidence that there's going to be low risk. So it's just about the point about making sure when you're doing permit applications or providing information to the EA that you are just there giving them the evidence to give them all the reassurance that they need. Next slide, if possible. So just coming on to sort of consultations and updates, and I'm conscious that some of this stuff is being talked about later, so I'm just mentioning it at the stage. So there's a consultation out right now. It came out, I think, 2 days ago, and this is about the requirement for site conditions reports and updates to guidance of that. So there is a consultation. This is my point about things, the goalposts changing. Things do constantly get reviewed and updated, so you have to constantly be aware of what's going on. There's what's called the H1 screening tool, which is used as part of permit applications to screen whether there's impacts on the environment. This is being updated at the moment, and will hopefully come out soon. There's the decarbonisation readiness, which will be talked about later. Then there's standard rules permits. So there's consultation on carbon capture storage for those, and about whether they can be incorporated into standard rules permits, which would be useful. There's also, it's worth mentioning that the Environment Agency are updating the permit application process and management system and having a new online website, which is hopefully going to become available in the future. Next slide, if possible. So just quickly mentioning sort of where I think we're going. Obviously, hydrogen and carbon capture integration is happening. That's the decarbonisation readiness side of it. That's a big piece which will be talked about later. I've seen that there's more and more R&Ds, research and development funds, for things that are looking at sort of digital monitoring and AI. So it's certainly funding in the research and development side of it to look at cloud-based platforms for real-time emissions mapping and optimizations of abatement strategies, linking it to back compliance and cost effectiveness. So that's something that I've seen on the R&D side that will probably come through to the operational side as well. Obviously, there's a bit move to dry anaerobic digestion, biogas upgrading systems, and the last one I thought is useful to mention is microsystems. We're sort of doing a lot more stuff at the moment with helping people where there's benefits in having a larger AD operation, but there's also seems to be more and more smaller ones that are potentially coming through as well. So it's just worth mentioning that there's both ways that we're going. Next slide, please. I am getting towards the end of my slides. Climate change, a big thing to mention. I've just put a screenshot of the EA's Chief Regulators Report, just highlighted a paragraph which points out that there is climate change is a big thing, and the EA are working with operators to do it to make sure that facilities are resilient to climate change. I put a comment in there purely to say that the EA look at a very long time horizon in terms of climate change, sort of 100 years, and provide stats that actually AD plant often 25 to 30 years for a lifespan, and so it's not directly relevant, all of the stuff, and you've got to consider that when you're doing climate resilience. The assumption is that after that stage, plant will be upgraded, things will change. And then the decarbonisation agenda is part of that climate change, minimising the impact on climate change. And then gas leaks is the other thing, I'd say. Methane emission leaks as a big part of the impact. Next slide, if possible. I think I've got 2 slides to go. So decarbonisation, this is, as I talked about more in detail later, but there's a series of requirements that you need to put forward in decarbonisation ready reports, and just answering a series of questions. These are the key date is the 28th of Feb next year, and we ourselves have been setting up templates for how reports work and putting together the relevant sets of evidence. But that's just a slide there with a link to the regulations if it's useful. If you get to the next slide, please. I just wanted to mention leak detection. Obviously, methane is a significant source of GHG emissions, and I think that this is going to be a bit of a focus for really minimising it. The biggest impacts, from my perspective, are in terms of climate impacts are from the leakage, and we certainly work with a monitoring company that are very much moving towards the AI and continuous monitoring systems, and it's just going to certainly be a way, that direction I think that they'll be expected to go in terms of understanding what emissions are, minimising leakage. And then I'll just go to the final slide, which I think is this is just a summary of our services. So I won't go through what it says on the slide. I'll just say that I've just rattled through super quickly some topics in order to then tee up the next conversations and next topics, but I kind of wanted to express that everything with operating an AD plant requires you to continuously improve and continuously stay up to date, and it's you can't just assume that you've got your permit and you're doing the bare minimum to satisfy that. You do need to demonstrate that you are improving and doing the best you can, and that there's obviously cost benefits of doing so as well. So that was the links in the slides are there to point people in the right direction for knowing where the information is to keep up to date. So I think that's the end of what I was hoping to say.
Thank you so much, Kieran. I think quite a lot of good information in there for everyone to sink their teeth into afterwards, for sure. So now we'll move on to the EA presentation, starting with Daniel. Thank you.
Good morning, everyone, and thanks, Kieran. You've done quite a lot of my job for me there. It's very useful. Yeah, just to reiterate that there's a lot of developments in AD that happen a lot. So my talk will just talk about some of those key changes that are coming in the sector. So it'll be a bit more focusing on a couple of key issues. So I'm Dan Persklov. I'm a senior advisor at the Environment Agency, focusing on biowaste treatment, but primarily AD in recent years. And I will kick off. Could I have next slide, please? So I'm going to talk about three things: the resource frameworks, changes to our standard rules, and DEFRA's environmental permitting consultation. I'll just kick off with resource frameworks. And if you may or may not be aware that previously these were called quality protocols, and what that is if for your output digestate, it can be considered to be a non-waste and be applied as a non-waste organic fertilizer to land if they meet certain requirements. So that's meeting the PAS 110 British standard for quality of digestate, and also if it's done in line with the quality protocol. But in October this year, the quality protocol was replaced by what's now called the resource frameworks, and we've published them for compost and digestate. These were produced along with other bodies like the REA, ADBA, and RIEL. I'll have to write those acronyms down for you at the end if you're not aware of them. So some big changes that took place with these quality protocols. There was a long list of wastes which were allowed to go in to make your digestate. Those have been restricted and removed certain specific codes which pose contamination risks, so wood wastes, and tightening of descriptions which sort of align with our standard rules. And probably the key point within this resource framework is where we consider the end of waste point to be. So if you've got a PAS compliant digestate that's met the end of waste tests, it happens when it's been dispatched or stored when it's certain that it will be used. So that certainty of use is an important piece of information from the Waste Framework Directive. So if we're confident that it's going to be used for the purpose that it's been produced for, then it can be considered end of waste. That high certainty of use is, we've sort of explained what that is in the resource framework, and that's when the producer and the receiver, the producer knows that the receiver has a nutrient management plan. So some of the points that Karen mentioned about spreading your digestate to land can have a potentially pollution risk. So those receiving the digestate should hold a nutrient management plan to know that what the crop and soil needs are for that particular organic fertilizer. Also, storage of digestate on site for longer than 10 months would indicate that that material doesn't have a certainty of use, and it would potentially be a waste still, because sort of indefinite periods of storage indicate that it's not going to be used for anything in particular, so that we would consider that to be waste after that point. So that's all set out in the resource framework. There's also some tighter plastic contamination limits, which is now specified as greater than the PAS 110 standard. And then to deal with because of the changes on the or the clarification on where end of waste occurs, we've set a transition period to allow operators and producers who need to store for longer than 10 months to obtain the appropriate waste storage permit. So you may legitimately need to store for longer periods, over a year, for example, which is fine. It's just that would be considered a waste. So you'd need a waste storage, like maybe a lagoon permit for that. And this transition period will allow any of those operators to store as they are until 31st of March 2026, and that's through the RPS 358. And this resource framework will probably be subject for another review in next autumn, when RIEL's research hub have completed their detailed risk assessments for compost and digestate, which will mean that there may be some further changes, but it's a useful document to keep abreast of because it will potentially change next year as well. Next slide, please. The next significant change in the sector are, so for our standard rules permits, they currently don't allow the capture and storage of biogenic CO2. We published an RPS on this 255, which allowed AD operators who did do the biogas upgrading, to capture the separated CO2, but we wanted to formalise that, and so with part of the decarbonisation readiness work that Emma's going to talk about, we asked to include these changes in our standard rules. And what we're consulting on is to add new techniques to allow operators to do physical separation of CO2 and to capture that. And it has the same storage, would have the same storage restrictions as the RPS, so 6 months storage of CO2 and 150 tons at any one time. So it's a reasonable amount of storage for small to medium sites. Mainly we're doing this because at the moment you have to get a bespoke permit if you want to do carbon capture. So it's off-putting for operators who want to operate standard rules but also want to do carbon capture. The production of CO2 is not for the purpose of sequestration, it's for the use to be sold into the food and drink industry or other industries who may need carbonisation resources. And importantly to note that this isn't a mandatory requirement, so it's a change to standard rules, but it's an optional aspect, so it's not a requirement for companies who operate AD to do carbon capture, but it's to facilitate that within the standard rules. Can I have next slide, please? And then the third sort of key update that's taking place. Could you just move? I've got a couple of pictures on there. That probably hasn't come up. Thank you. So DEFRA has consulted on modernising environmental permitting, and that covers a really broad range of aspects that Kieran touched on a little in his talk. But the key bit for you listening, I suppose, will be the proposal to bring crop-fed and non-waste AD into environmental permitting. So that's part of there'll be a regulatory legislative change to the environmental permitting regulations. That would likely be a Part A1 installation activity. We definitely support this because the risks from AD facilities are similar regardless of feedstocks. You may have slightly different environmental challenges with different digestate, but they both still produce biogas. They both, if you spill digestate into a river, it's going to cause pollution. So we're pleased that it's being brought into regulation, hopefully. Many non-waste AD activities probably take place at capacities below the 100 tons per day threshold, which is the current capacity size for a waste installation. So we've fed back to DEFRA that we'd like to see smaller capacity non-waste ADs covered by these reforms as well. That consultation unfortunately closed on the 21st of October, but hopefully some of you may have seen it from other sources. And just touching on what Kieran said, we would want these non-waste AD activities to meet the same level of standard as waste AD that's outlined in the biowaste appropriate measures. So that means the leak detection and repair, emission limits on odour and ammonia, and appropriate infrastructure. Jenny, you already just can play on that as a video. If you just go back a second. Sorry, if you go back to the previous one, previous slide. Thanks. So this is just an example of an optical gas imaging camera. Apologies about the fuzziness. Why non-waste sites need to be considered on a par with waste. So amongst all the graininess, you can see bubbling in this digestate lagoon and venting of biogas, which poses a serious environmental health and safety risk. And that is currently completely unregulated. Next slide, please. And so last point, sorry, I realise I've taken up too much time. Biogas leakage, so just expanding on the last point and on what Kieran said, the key and probably the biggest priority for us in AD is biogas losses, and it can occur from dome membranes, incorrectly operated pressure release valves, open digestate storage, leaks from flanges and pipework. And so some of you may be aware that DESNES produced a document called the MEAD report, which stands for methane in anaerobic digestions. That was last year, and it included a study which assessed methane leaks from AD. And most of these case studies in that was from agricultural plants, so crop-fed manure or a mixture. And it found that losses of methane ranged from between 4.1 and 14.2% of the methane produced in those 8 individual AD plants. So biogas is invisible. Operators won't know it's happening. So Jenny, could you press play, please? So just to highlight some of those losses, this is methane emissions using, again, no GI camera, leaks from pressure release valves, which have inappropriately been activated while the CHP was down. So these sort of gases should be going to the flare in these emergency situations rather than venting out the top of the tank. So there shouldn't be any venting of gases when it's not safety critical, but sometimes without the sort of leak detection and repair checks, you don't know that this is happening. And it can be quite significant losses of biogas, which is a loss of revenue. At the end of the day, it's a loss of what you're doing the AD for, to generate a gas that you can combust, burn it, get the electricity, and even upgrade the gas into the grid. So yeah, just to re-emphasize the importance of the leak detection and repair aspects of the permitting. And even if you, at the moment, even if you operate a site which isn't regulated, doing the leak detection and repair aspects would be very good practice for you to prevent losses of methane. And that's it for me. Thank you very much. I'll hand over
Thanks
to
so
Emma.
much, Dan. Yes, we'll hand over to Emma and let her carry on the second half. Thank you.
Good morning, everybody. Yeah, my name is Emma Preston. I'm a senior advisor and project manager, and I'm responsible in the Environment Agency for the implementation of regulatory controls relating to medium combustion plant and specified generators. It's a very big and complex topic, and I think I've only got about 5 minutes left, so bear with me. I'll try and trot through this as quickly as possible. I think the key thing I want to get over is to sort of highlight to you the relationship with, obviously use of biogas as a result of doing AD activities and in combustion plant, which often follows that activity, and just sort of make you aware of what those requirements for permitting and compliance are. So we'll just move on to the next slide, please. So the requirements for controls on emissions from medium combustion plant comes from the Medium Combustion Plant Directive, and that was then enacted into law through environmental permitting regulations. It requires medium combustion plant and specified generators to be permitted. So this slide is talking about specifically medium combustion plant and which ones of those would require a permit. So if you've got a plant that's got a capacity of more than or equal to 1 megawatt thermal and less than 50 megawatt thermal, burning any fuel, in this case most likely biogas, then it would fall into the requirement for a permit. Those operations can be static or they can be mobile plant. They can include backup generators for emergency use. They might be standalone, or they might form part of an IED Chapter 2 installation, where they might be a directly associated activity to the primary activity taking place, or they might be part of a waste activity permit. So it depends on the scale of your AD facility and what the inputs were, whether they were waste or crop fed, as to what type of permit you might need for the combustion side of use of that biogas. So the sorts of combustion technology we're talking about here, probably with AD, mainly boilers, engines and CHPs, which is the combined heat and power. And sometimes they're for heat and sometimes it's for electricity. Any abatement that you've got associated with that, stacks, flues, air cooling, that all forms part of the medium combustion plant that we're looking to control. We'll just move to the next slide, please. So who might need a medium combustion plant permit? I've sort of put up a number of different questions. This is quite complicated, but first of all, I would sort of recommend that you determine whether you would actually be excluded from the requirements. For example, if you're only burning combustion of poultry litter, they are excluded, or if you're doing direct heating and drying, there's exclusions that apply in those cases. It's also a good idea to work out whether your plant is new or existing. If it was installed before the 20th of December 2018, it's what we call existing plant. And if it was after that date, it's new. If you substantially refurbish your older plant, and there's definitions of this on our website, you may then start to become a new medium combustion plant. So it's worth watching out for that. Understanding what your capacity is really important. We use input capacity in megawatt thermal using net calorific values. So input capacity rather than output capacity. That's a common mistake that's made. So if you're not sure, you can go to the manufacturer of the combustion plant to determine that. Sometimes it's on a nameplate. There's various ways of working out that, and we've got some guidance on that on our website as well. If you operate new medium combustion plant, then we have some aggregation rules where that if you've got more than one combustion plant on the same site for the same purpose. So aggregation, very important, only applies to new medium combustion plant, not existing. Again, another common error that's made. So I've already mentioned if you're doing crop fed AD, it may be that you don't need a permit for the AD side, as was just been discussed with Dan, or not yet anyway, but you may need a standalone medium combustion plant for the burning of the resultant biogas in a combustion plant. If you're using waste in your AD facility, you'll probably, and depending on the size of that facility, you may have a waste permit, and we can add on to that the combustion elements as well onto that same permit. If you're a larger scale AD facility, you might have an IED Chapter 2 permit, in which case your combustion might be a DAA to that facility. So we're talking about intensive farming, sludge treatment, or those larger scale waste AD facilities. Then what's important here is whether your medium combustion plant is generating electricity or not, because potentially you may also be a specified generator. So I'll now go on to explain on the next slide, please, Jenny, what is a specified generator. These are combustion plants that generate electricity. So it's not. So if you're a combined heat and power, that would also be considered to be a generator. But if you were just doing heat, you would only be an MCP. So it can be one generator, it can be a group of generators at the same site by the same operator for the same purpose. The difference with medium combustion plant is that the de minimis is different. So it can be anywhere above 0 megawatt thermal up to 50 megawatt thermal. So when this kicks in is can be for smaller generators than when you're just a medium combustion plant. Hopefully that makes sense. Next slide, please. So in terms of deciding if you need a specified generator permit in addition to the medium combustion plant one or instead of, first of all, there's questions around, are you actually excluded? Again, emergency backup is excluded. If your activity is taking place in IED Chapter 2 facility, then the requirements of specified generators forms BAT instead of you actually needing that activity to be permitted as a specified generator. Again, you need to work out your capacity. It matters exactly when you got your capacity market agreement or FIT agreement. The number of hours that you operate and the emissions of your NOx all determine when you might, or if you need to apply for a specified generator permit. I've put a link on that slide there that sort of goes off to our guidance that talks you through these questions in more detail, but they're the sort of high level information that you would need to determine whether you need that permit or not. Next slide, please. So this is quite an important slide. So this gives all the timescales for implementation of medium combustion plant specified generator controls. So when this was brought in, it was a three-phase approach. We've just sort of concluding phase 2, and phase 3 are those bottom 2 rows, which are coming in 2029 and 2030. So I can't have time really to go through every single one, but the important thing is that it's medium combustion plant between 1 and 5 megawatt thermal, which are existing, which may apply to many of you, which are going to require permitting by 1st of January 2029. And this is really the main purpose of my presentation, is to make sure that you are aware of those requirements and can sort of prepare and be ready for permitting. And obviously being able to meet the emission limits and monitoring requirements that we'll be applying in those permits. So just move on to the next slide, please. So when it comes to you making your permit application, we've got lots of guidance on our website. We've got a pre-application service with our permitting service, and obviously use of consultants. And I know many of them have been sharing with you what services they offer, if you feel it's not something that you can do on your own. Next slide, please. So in terms of what compliance you might be expected to do, we take the emission limits from the Medium Combustion Plant Directive. They're the ones that we'll use in the permit that you get given. And I've just put a little screenshot there of part of the Medium Combustion Plant Directive, which relates to existing engines and the sort of the levels of SO2, NOx and dust that you'd be expected to reach. And so anybody can go, before you've even got a permit, you can go to the Medium Combustion Plant Directive and know already what we're going to put into your permit, and that means that you can prepare for meeting those emission limit values in advance. There's quite a few footnotes that go with it, so it can take a little bit of interpretation, but I noticed Sophie's just dropped in there. If anyone wants any help with that, she's available. Yeah, so you can sort of see there what they are. And then if you have a standard rules permit, we have monitoring called the low risk method, which is there to sort of mean that hopefully that monitoring is not too costly for you. You can get handheld probes that allow you to do the monitoring. If you're on an IED facility or a sort of bespoke, more complex or risky facility, then we require MCERTS monitoring. Next slide, please. So looking ahead, I'm just going to talk about DR in a moment, decarbonisation readiness. We're going to be developing standard rules for existing 1 to 5 megawatt thermal medium combustion plant specified generators, so look out for future consultations on that. It's already been touched on the DEFRA EPR reg reform consultation that happened earlier this year. There was quite a few things in there in relation to medium combustion plant specified generators. We don't know yet which way that consultation is going to go. We're waiting on DEFRA's consultation response. But there's a possibility there might be some quite significant policy changes in relation to how we permit or maybe don't permit these things in the future. So very much recommend that you click on that link and join our mailing list, and we'll keep you up to date with all those changes. What I've described today is what's in the regulations at the moment. But as I said, if things change, then we'll be keeping you informed via that mailing list. We've also got a number of digital portals which we're in development in the Environment Agency, which is going to in the future mean that you're able to make your permit applications online rather than filling in PDFs and Excel spreadsheets, etc. And also in the future, you might be able to submit monitoring returns. We've got a number of trials already going on with standard rules permits. So yeah, that's in development and hopefully modernising our service. So the next slide, please. So these are just 2 slides I've got on decarbonisation readiness. Oh, we've lost it. Yeah, there we go. So this is a brand new piece of legislation that was introduced into EPR. It's in what's called Schedule 25C of those regulations. In there, it says that from the 28th of February 2026, if you apply for a new or substantially refurbished electricity generator permit, that you will be required to meet decarbonisation readiness in accordance with the legislation. So what does that mean? So if after that date you apply for a new or substantially refurbished generator, you will have to demonstrate through the writing of a report that you're ready to operate a carbon capture and storage system, or that the plant would be ready to operate on hydrogen as a primary source of fuel. Now, obviously for AD, you're not going to be moving to hydrogen, so carbon capture and storage system is it will be the option that you'll be looking to write into your report. So it's not saying that you're going to install that right now. It's really a report that says how you'll be ready to install that in the future, and that there's no barriers to you being able to install that equipment in the future. So it's mandatory for new or substantially refurbished electricity generators, but you can also choose to make a voluntary application for DR assessment for your existing plant if you want to. In some instances, people who are participating in the capacity market will find that beneficial, but yeah, it's voluntary. The primary requirement is that DR report, and in demonstrating that you've got carbon capture and storage system availability, it's about, have you got the space requirements? Is there technical feasibility of retrofitting this equipment in the future? Do you have the necessary transport, storage, fuel access, and will it be economically feasible? So those are the key areas within that report that you'll be looking to demonstrate. Next slide, please. So how are the Environment Agency preparing for decarbonisation readiness? We've had consultations out on our guidance, and now we have actually published our response to that consultation and published our final guidance. So there's plenty there to read about more about decarbonisation readiness, and put the links there on that slide. We've also got a couple of active consultations out at the moment relating to this new requirement. One is amendments to standard rules permits involving combustion activities. So the AD standard rule sets, medium combustion plant specified generator rule sets are all being updated, and we've made recommendations of the sorts of permit conditions we want to put into those standard rule sets for DR. There is also, which hadn't been launched at the time I prepared these slides, but there's now a new consultation on the charges that we'll be making in order to assess decarbonisation readiness reports. So I can put that link in the chat shortly. So that was a very quick whistle stop tour. Sorry about that, but more than happy to take questions at the end. Thank you.
Thank you, Emma. It all is very, very important. So if people can bear with us, and we'll go a little bit over time, but David's got some fantastic things to talk about as well with what Purigen are doing. So on to David. Thank you. You're on mute, David.
Yeah, sorry guys, I'm just trying to take control of the slides, but struggling a little bit. Jenny, I'm going to have to ask for your help with this. So yeah, my name is David Ray from Purigen. We're an activated carbon company. Just want a quick whistle-stop tour through the use of activated carbon for biogas and biomethane, and focusing particularly on the specific issue of the biogas sector, which is high sulfur levels. We could have the next slide, please, Jenny. Just 3 clicks, just to, so who are we? We've been around for over 35 years, based in the UK. You may know us as CPL, Activated Carbons, but we've grown rapidly over those years. We've made acquisitions in different countries. Now we have operations across 9 countries, you can see them there. And we're basically a global leader now with revenue of €100 million globally. And so, yeah, we've grown from very humble beginnings in a little office in Wigan to a global player, just to let you know who we are. Next slide, please. Just give us a few clicks, Jenny, thanks. So what is activated carbon? It's basically a pure form of carbon with a very high surface area. We say a dessert spoon has a surface area of 1.5 football pitches, and you can see it's made up of those pores. You can see on the top right there. Different raw materials, coal, coconut shell, wood, giving you different properties for different applications, and different physical forms as well. You might be familiar with granular, GAC, powder, or pellets. Typically for gas phase, you'd have the large GAC or the pellets that you can see at the bottom there. And it works by trapping impurities in those pores. The process is called adsorption. And generally, that's a reversible process that allows us to recycle the carbon. We do that here in the UK. Just keep pressing, Jenny, if you don't mind. And yeah, hundreds of applications, water, drinking water, wastewater remediation. And on the gas phase, you've got odor control, biogas, purification, VOC abatement, respirators, lots of things. So specifically for biogas and biomethane, just one more press, Jenny, please. So you've got two broad types. You've got your siloxanes and VOCs, your organic pollutants, and you use standard GAC or pellets for those. And then for your inorganics, hydrogen sulfide and ammonia, we tend to impregnate the carbons with functional chemicals because those impurities aren't very readily removed by standard carbons. So two broad types. Next slide, please. Give me a few press. So how do customers use carbon? Well, increasingly they look to our range of mobile carbon filters. We design and manufacture these in-house at our site in Chesterfield. Aquasorbers for liquid phase and Voxorbers for gas phase, and they range in size from the small drums. You can see one of the drums on the far right there, up to our largest 30 cubic meter truck-based solutions. You can see one on the middle there with a green one next to a biogas dome. And they give customers a convenient plug-and-play solution. We deliver the filter full of fresh carbon, and when it's spent, we replace it with a replacement filter full of fresh carbon and take the spent away for recycling. Obviously, there's no on-site carbon handling. You don't have a pile of black granules that might be smelly, dusty, or even potentially flammable if it's had biogas through it. So we take that away and we handle all the carbon at our service centres. And it's obviously modular. You can add multiple filters in series or in parallel. If there's a spike in, for example, H2S, you might want to add a second filter specifically targeting H2S. Or at a landfill site, if the gas volume might go down, you might want to take away, one of multiple filters. And we rent the filters to our customers, so it's essentially a CapEx option. And it opens the door to our change-out service, which I'll talk about on the next slide, please. Wherever possible, we recycle our spent carbon. The main reason for doing that is a huge carbon footprint saving. It's with coal-based carbon, it's about a 93% carbon footprint saving. Keep pressing, please. We have three separate processes at Immingham. We have a green list process for specifically drinking water and food, which obviously is completely separate to our big amber list process for industrial and environmental. So that's your odor control, your VOCs, that type of thing. And we have a very specific third process looking at high sulfur carbons coming back from biomethane, biogas, and landfill gas. Important to stress, we are the only amber reactivation capability in the UK. Anyone else taking spent carbon from you will be either disposing of it or sending it overseas for treatment. And we have on-site quality labs for QA as well. Might be the last button. Next one, Jenny. So, yeah, what is the problem with high sulfur? When it's heated in a standard reactivation kiln, that's our big amber kiln there. It's one of the biggest in Europe, but it's here in the UK. It basically dumps elemental sulfur everywhere, and that's a big problem when you've just spent several millions of pounds on a reactivation kiln. The second stage of the orange thing next to it is a thermal oxidizer. So in the presence of oxygen, it forms sulfur oxide, SOx, which is a toxic and hazardous gas. And spent carbon is obviously moist as well, coming from biogas streams. So you can form sulfur-based acids, sulfuric acid. So you've basically essentially got hot acid rain sloshing around a multi-million-pound kiln. So for all those reasons, our industry has traditionally not wanted to touch high sulfur carbons. Rewinding a bit, in the early days, you might get 10% loading of sulfur on a spent carbon. That was considered a good performance. And at those levels, our industry could traditionally treat spent carbons. You might blend it with other feedstocks and be able to cope with that. More recently, the next bullet point, the latest impregnated carbons, we're seeing up to 40% loading on sulfur. That's quite normal. At that level, you basically 100 kilos of spent carbon gives you 40 kilos of sulfur. At that level, you have to basically treat it as waste, and our industry has traditionally landfilled or incinerated those kind of spent carbons. So that's the problem. Next slide is our solution. So after an extensive R&D program, we can now safely and economically handle these heavily loaded spent carbons. 40% sulfur loading is possible, and we're doing that on an industrial basis, and it prevents, carbon, allows us to process carbon that was previously considered waste. Pressing. And we've been operating this process since the second half of 2023, and it's a unique capability within the sector, certainly here in the UK. And we've won multiple awards for our technology. We're very proud of our technical leadership in this area. We're not standing still. We're trying to future-proof it by looking at 80% loading of sulfur, and we're able to do that on a lab scale. Hopefully, we can do that on a commercial scale going forwards. And this forms our third process. Again, green, amber, and then CR3, carbon reactivation 3, is specifically for your sector, for biogas and biomethane. Next one's a bit of a cheesy photo, I believe, of all the awards we've won. Yep. So we are, part of my role is to celebrate and communicate. So we've won multiple awards, including the big one at the AD Biogas Show at NEC in July. We won one in Italy earlier this month, and last week I was at the House of Lords picking up another award, a Green Apple Award for this technology. So we're getting the message out there that we have a solution. A couple of very quick case studies. We're retrofitted where a customer hasn't previously had carbon, but it allows us to show our full engineering prowess. This was a landfill gas site where they had problems with siloxanes and hydrogen sulfide. The siloxanes were linear short chains. That's a particular issue. We just press on the next, it shows the solution. So install 2 of our 2 cubic meter Vox Orbers, you can see them in the picture there, plus all the pipework and connections. Again, we can supply the full engineering package. We offered a coconut carbon for the shorter siloxane removal, again, specific carbon for a specific problem, and impregnated coal-based carbon for hydrogen sulfide. Again, two carbon filters for 2 solutions. Next slide, please. This is a much bigger scale biomethane site. The OEM for the biomethane solution did provide some small plastic carbon filters that are very small, insufficient for the hydrogen sulfide levels they were getting, and they're changing the carbon out every 3 to 4 weeks with downtime. So basically have to turn the biogas off. And as you know, if you're not pumping biogas, you're not making money. So our solution, next bullet point, we added one of our largest filters, a Voxorber 30. We initially had 2 units, later reduced it to 1, and now they're changing out every 6 months. With 0 downtime, we've arranged the pipe work so that they can bypass the carbon filter through their fixed filters. There's no downtime. They can keep producing the biomethane and keep making money. So that's how we work with customers in a partnership approach, trying to solve problems and improve their outputs. Next slide, please. I think it's the final one. So in summary, we want to be this one-stop shop to help customers solve their challenges. We have our activated carbons, our Voxorber filters, our e-access recycling program, and all the support in terms of engineering, site services, and quality control and application support. Next bullet point, please. And we believe we've shown technical leadership in terms of activated carbon purification and recycling with our award-winning CR3 high sulfur process. What does it give biogas operators? Well, operational, this age-old problem of what to do with the waste carbon. In terms of environmental, improves your credentials of your site. And financially, you're not paying for disposal of hazardous waste. We have a no hidden fees policy as well, so we don't hit with customers with surcharges if the spent carbon is more tricky to handle than expected. Final slide, please, Jenny. So thank you for your attention. Again, that's a bit of a rush through. Please, my contact and my colleague Matt Goff is our biogas expert. He's with me as well here. Please come back to us if you want any more details, if we have projects you want to discuss. I'm happy to take questions now. So thanks again for your attention.
Thank you so very much, David. That was very, very interesting. Lots of fantastic solutions there for our industry as well. I have noticed that we haven't got any written Q&As in the chat. So if anyone does have any that they would like to put in, feel free to raise your hand. I'm aware that we're a little over time, but I'm very grateful that we managed to get all the speakers to get through their content. Raised hands. Okay, you can always stop us an email as well if you do have any questions. If you want to go to the last slide, Jenny. So yes, thank you so very much for joining us today. I hope you've got something out of that. I know I definitely did. As I said, we are going to be sharing the recorded presentation, and if you do have any questions, feel free to drop us an email, and we can get those answered by our speakers for you. Next webinar we will be hosting will be on the 11th of December, and that's about the recent update to standing charges, and most importantly how we can make sure that you're not going to be impacted so severely by it, because I know there's some really scary percentages involved with that. Thank you again to all the speakers. You've been fantastic.